let's talk about the reflections of functions. So to start, if you could go into just desmos.com and input the square root function, and then start playing with just negative signs. So put the negative maybe before the square root or under the square root with the x, and just try to get an idea of what happens when we start putting in these negative signs. See what happens. And then once you're done that, come on back to this video. Okay, so reflections happen when we have these negative signs, whether the negative is outside of the function. So for example, if we're going to look at the function, the square root function, so let me just graph it. Square root is 0, 0, 1, 1, 4, 2, so it looks like this. Then what happens when we have this negative sign in front of our function? So the negative sign means that we're taking all of our y values, our output values, and we are multiplying it by -1. And so what you should have noticed with Desmos is that we end up with a reflection, and that reflection happens in the x-axis. So if this is my table of values, for example, 0, 1, 4, 9, 0, 1, 2, 3, when we have this negative sign outside of the function, it's being multiplied to the whole function, what we actually end up doing is multiplying our y coordinates by -1. So let's multiply all our y coordinates by -1. And what we end up with is 0 times -1. Sorry, put the negative there, which is 0. 1 times -1, which is -1. 2 times -1, which is -2. And 3 times -1, which is -3. So now the points that I'm going to plot are 0, 0, 1, -1, 4, -2, and 9, -3. And as you can see, what happens is we end up with our function looking like this, which is, it's just been reflected in that x-axis. Okay, so if the green one was our original, so let me put the original back on. There's my original. Okay, f of x. Then here is my g of x in blue. Okay, and as we can see, it's just been reflected in that x-axis. So just to let me put a highlighter here. So it's reflected in that line. Okay, what if the negative sign is under the square root though? So again, let me put my base graph down. Well, this time, if the negative is underneath, then it's being, the x values are being multiplied directly by -1, so times -1. So -1 times 0, which is 0, -1 times 1, which is -1, -1 times 4, which is -4, and -1 times 9, which is -9. And so now notice that I have multiplied all my x values by -1. And so let's take a look at what happens here. So 0, 0, -1 and 1, -4 and 2 gives me this function right here. So h of x. Well, if my original function is this function, so this is my f of x, then now we can see that we actually have a reflection, this time though that the reflection happens in the y-axis. So if our negative sign is out front, it's being multiplied directly to the whole function, it's going to be a reflection in the x-axis. Whereas if the negative is under the square root sign and it's directly to the x, then it's going to be a reflection in the y-axis. Okay, so these are kind of our notes, I guess, for the day with a little example. Given the function f of x, then g of x equals negative f of x is a vertical reflection. So that's what we call it, a vertical reflection, because it's taking something that was up and then reflecting it down. So that's a vertical reflection across the x-axis. Okay, and so we can see this. So one way you can just reflect this directly on the graph if you wanted to, but I'm actually just going to pull out some points. I always like to pull out the points so I can see what's happening. So -3 and 2, 1 and -1, and 3 and 3. So since I'm multiplying f of x by a negative, that means that's my y values. So I'm multiplying by -1, and I get -2, +1, and -3, which means my new points are at -3, -2, 1, 1, and 3, -3. So let's see what happens when we plot those points. So -3, -2. So we can see, if we actually look at -3, +2, we can see now how that's a reflection over the x-axis. 1, 1. Again, we can see that reflection happening. And then 3, -3. And now if I connect, this is, if this is g of x, this is negative f of x. Okay, same thing. Oh, I guess they wanted me to do it over here, but I did it on the same graph. So we'll just take this away. Delete, we didn't need that. All right, so we can see, I like putting them both on the same graph because then we can actually see that reflection that's going on and kind of double check that everything was reflected across my x-axis. So it was reflected right there. Okay, same thing here. If you notice that the negative sign is inside, it's directly to the x on the inside. So again, I'm going to just take these 3 points, put them in my table. So -3, 2, 1, -1, and 3, 3. Now what happens is I'm going to multiply all my x values by -1 because that negative is being multiplied directly to the x. So that's why we're going to multiply -1 directly to our x values. I get 3, -1, and -3. So my new points are going to be at 3, 2, -1, -1, and -3, 3. So 3, 2 is over here. So we can see, if we look at -3, 2, we can see that reflection across our y-axis. And then I have -1, -1. Again, we can see that reflection across our y-axis. And then -3, 3 is right here. And again, we can see that reflection directly across our y-axis. So now I can combine those. So this was our h of x, was our original. And then this is f of -x in the green is our reflection. And that reflection came from the y-axis. All right. So how can we put this together with what we've been doing? Again, here's another example for you to try. This time they want us to do both reflections. So they want us to take f of x, and they're telling us g of x is equal to a negative f of x. So g of x is going to be a reflection in the x-axis, where h of x is going to be a reflection in the y-axis. So they just want to reflect this twice. Again, let me pull off these 3 points. So this is f of x. So f of x, x, and f of x. Here we go. So -6, -3, -3, 4, 3, 2, and 7, 7. So if I'm going to look at g of x, that tells me that I want to multiply all my y values. I'm going to multiply f of x by -1. And so Negative 3 times negative 1 is positive 3. 4 times negative 1 is negative 4. 2 times negative 1 is negative 2. And 7 times negative 1 is negative 7. So let's go ahead. Let's put g of x on there using my new points. So negative 6 comma 3, negative 3 comma negative 4, 3 comma negative 2, and 7 comma negative 7. So negative 6, positive 3. Look at that. We can even see the reflection now happening over our x-axis. Then negative 3, negative 4. Again, we can see that reflection. 3 comma negative 2. And then 7 comma negative 7. And now, if I connect my points, this is my g of x. Okay, let's try this again. This time, though, I'm going to do an h of x. So negative 6, negative 3, negative 3, positive 4, 3 and 2, 7 and 7. So let's do this in blue. Now that negative sign's being directly to the x, so we're going to multiply by negative 1 directly to the x, and we get a positive 6, a positive 3, a negative 3, and a negative 7, which means my new points are at 6 comma negative 3, 3 comma 4, negative 3 comma 2, negative 7 comma 7. All right, and again, let's plot these on the graph. So 6 comma negative 3 is down here. And if I just kind of step back and look, I can see that that's a reflection over my y-axis. 3 comma 4, again, I can see that reflection happening. Negative 3 and positive 2. And then negative 7 and positive 7. And so if I connect these points, this is my h of x. All right, looking good. So if the negative is on the outside of the function, it's being multiplied to the whole function. That's when we multiply our y values by negative 1. If the negative is inside to the x value, that means that we are going to multiply all of our x values by negative 1, and we get that reflection in the y-axis. Okay, so let's take a look at the absolute value graph. So let's start by graphing that. So absolute value is our V graph. So negative 2, negative 1, 0, 1, 2. It's my base graph. And absolute value means whatever I put in, the positive comes out. So this becomes 2, 1, 0, 1, 2. Remember, it's that hard V that exists. So if I plot these points, here are my 5 points. And it looks like this. So this is my f of x. Okay, now what they would like me to do is they'd like me to transform this. So I'm starting with a negative that's outside my function. So negative outside my function means I'm going to multiply all my values by negative 1. So I get negative 2, negative 1, 0, negative 1, negative 2. So that should be a reflection in my x-axis. Okay, so this tells me reflection in x-axis. And then now we're going to take a look at this. If you remember, we're adding 2 directly to the x. This is going to mean 2 to the left. Remember, it's always the opposite of what's inside the brackets. And so if it's a plus 2 in the brackets, it's a negative 2 outside the brackets, which means I need to go to all my x values and subtract 2 from them. So negative 2 minus 2 is negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 2 minus 2 is 0. So now, coming up with my new points, you take your outermost columns. So negative 4, negative 2, negative 3, negative 1, negative 2, and 0, negative 1, and negative 1, and then 0, and -2. Okay, so what we're looking to see is, did we reflect this in the x-axis and then moved it to left? So let's plot our points and see what we get. So -4, -2, -4, -2, -3, -1, -2 and 0, -1 and -1, and 0, -2. And look at this. This is lovely. So notice there's definitely, it's been reflected, and then it's been moved 2 to the left. So we did it. Great job. So we can apply more than one transformation. It's just a matter of making sure that we're nice and organized in our table of values to see our new points. Okay, so let's take a look at the cubic graph. So if I take a look at the cubic graph, we have x and f of x. And again, it's -2, -1, 0, 1, 2, which is going to give me -8, -1, 0, 1, 8. This is our snake graph. Do you remember that? So -2, -8, -1, -1, 0, 0, 1, 1, 2, and 8. And I call it the snake graph because it kind of snakes up our y-axis, just like that. Okay, so let's take a look. So I'm starting here. I have this negative sign outside of my function, so that means it's a reflection in the x-axis. So that's where I'm going to begin. So right here, I'm going to multiply by -1. Okay, we always start, when we have more than one transformation, we always start to the left and work our way to the right. So whatever we encounter in our function, we deal with that first, okay? So that will follow the order of operations necessary when we have more than one transformation. So I got to start with that -1. So that's going to be 8, 1, 0, -1, -8. So that changes all my signs. Then I have this right here inside. So +3, x +3, that actually means 3 to the left. Remember, it's the opposite sign. So I'm going to subtract 3 over here from my x value, which is going to give me -5, -4, -3, -2, -1. Then I have this +2 right here, which means up 2. And remember, that is affecting our y value. So right here, I'm going to go +2. So 8 + 2, which is 10, 1 + 2, which is 3, 0 + 2, which is 2, -1 + 2, which is 1, and then -8 + 2, which is -6. And now, again, I'm going to take my outermost columns to make my new points. So -5, 10, -4, 3, -3, 2, -2, 1, and -1, -6. All right, and now let's plot this on my graph and see what we get. So we're looking for something that's been reflected in the x-axis. It's been moved 3 to the left and 2 up. So -5 and +10 is up here. -4 and +3 is here. -3 and +2 is here. -2 and +1 is here. And then -1, -6 is down here. So let's look at that. There we go. Isn't that beautiful? So we reflected it in our x-axis, which is why we get it's going kind of like in the opposite direction. So it was a reflection in the x-axis to start. And then we moved it over 3 places to the left and 2 up. All right. I'm so glad that we have a table of values in order to organize this. Certainly, if you can just visually see it and plot your 5 points exactly on the graph without having to do all the table of value work, you're more than welcome to. But I really like to push the table of values because it keeps it all kind of organized. And then if you make an error, of course, then it's easier to see where that error is. Okay. So predict what the function will look like, then use Desmos to verify your answer. So start with just thinking about what do you think is happening here. We have a negative underneath and we have that +3. So what do you think is going to happen? Then put this function into Desmos and see if your prediction was correct. So the negative, this negative tells me that there's going to be a reflection in the y-axis. But if you are thinking that this is moving 3 to the left, you're actually incorrect. Remember that whenever we go to find how it's moving, like left or right, you actually take the whole thing and put it equal to 0 and then solve for x. And normally we just cheat, right? We just change the sign. But if you actually take this out, this negative x plus 3, and put it equal to 0 to solve for x to figure out which way it's going, what you'll notice is that we subtract 3 from each side, so you get negative x equals negative 3. And then we have this negative in front of the x that has to be divided each side by negative 1. So x equals positive 3. So this is actually moving 3 to the right. Now, one of the ways that we can do this to show it actually in our function is we can rewrite this function, f of x equals the square root, and we can take that negative 1 out, that negative outside the brackets. Actually, I don't want to even put it as a negative 1. I'm just going to put it as a negative. So I'm going to take the negative out of the brackets, which would leave me with x minus 3. And then it's easier for us to read, oh, look, I have this negative 3. That means 3 to the right, or positive 3. Okay, so if you notice that you have that negative under your brackets, that's great, but you also have to take a look at the whole equation. And if it's not written kind of as a separate entity where it's the negative and then in brackets what's going on, you'll need to do that yourself. So it's just a quick common factor, and then that will allow you to see what's going on. Okay, so from here, you want to create your table of values, starting with your base graph of the square root graph. So x, f of x, square root, remember we always use those numbers that we can actually find the square root of. So 0, 1, 4, 9, and 16, which gives me 0, 1, 2, 3, and 4. And then from there, I'm going to go ahead and use this actual function that we just rewrote. This negative, of course, means that we are going to multiply all our x values by negative 1 because that's a reflection in the y-axis, which gives me 0, negative 1, negative 4, negative 9, negative 16. And then from there, that x minus 3 means 3 to the right. So let's add 3 to all of those, which gives me 3, 2, negative 1, negative 6, and negative 13. And now we have our new points that we can go ahead and plot. And see what this looks like. So what we should notice when we go ahead to plot this is that it should be a square root graph to start, should be reflected in the y-axis, so that reflection over that horizontal reflection, and then moved 3 to the right. So let's see what we got. So 3, 0 is here, 2, 1, negative 1, 2, 6, negative 6, 3, and then of course negative 13 is all the way out there. So this is our graph. It has been reflected across the y-axis and then moved to the right, so I know that I must have done this correctly. So this is just be careful, like when you're looking for negative signs that are directly to the x value, just also take a look, because if there is a horizontal translation going on too, you may need to common factor out that negative sign in order to see what's actually going on with your translation. Okay, and I think that brings us to the end. So on page 110, if you can try those few questions, make sure you graph. Here's a few extra I'd like you to also try and hand in. So these are to be handed in so that I can check, but you should check first Of course, we have access to Desmos right now, so make sure that you're using Desmos to double check your answers, that what you graphed ends up being what they have also. Remember, as always, if you have any questions, make sure you reach out and ask.